Hi everyone, I hope you're okay and I hope the videos are helping you out, guys. Now, this is the third video where I'm tackling a past question paper with regards to work, energy, and power. Please note that the first two videos are already uploaded, and the other 8 videos will be uploaded after this one. You can just click the link on the description below. There are two playlists over there. The first playlist, excuse me, will direct you to the playlist where I teach work, energy, and power from scratch. And then the other playlist, that's when I just apply questions in work, energy, and power. So please do choose, guys. Be fair to yourself, choose wisely. If you still want to learn, choose the first playlist. If you feel like you want to apply the knowledge you have, just choose the second playlist and answer the questions with me. Okay, before I even start, guys, please do share the video to your peers. A thing or two that I will mention here will help them either prepare for an upcoming test or an upcoming exam, or even help them elevate their knowledge in work, energy, and power. And please do like, comment, and obviously subscribe to help us grow the channel. Okay, we are told that a constant force F is applied at an angle of 20 degrees above the horizontal, and it pulls a 200 kg block over a straight distance on a rough horizontal floor as shown in the diagram below. Okay, so that's the initial position and that's the final position. Okay, the coefficient of kinetic friction UK between the floor and the surface of the block is 0.2. Okay, the first thing they want us to answer is to give a reason why the coefficient of kinetic friction has no units. For us to find the coefficient of kinetic friction, we must get a quotient of two forces. Basically, what that means is, for you to find the coefficient of kinetic friction, you must divide a frictional force and the normal force. F normal, are together. Whenever you divide these two things, remember that both of them are forces. A frictional force is measured in newtons. Normal force is also measured in newtons. So the two SI units will cancel one another, and then we will be left with the number. And hence the kinetic friction does not have SI units. Are you together? Okay. Then question number 2, they want us to state the work energy theorem in words. It simply says that the net work done on an object is equal to the object's change in kinetic energy. Okay, and then 5.3, we are supposed to draw a free body diagram indicating all the forces acting on the block while it is being pulled. Okay, your free body diagram can be like this. Since the block is in the universe, you'll obviously have the gravitational force. There is a force opposing motion because this is a rough surface, right? Fk for kinetic friction, there's weight, and then this object, the 200 kg block is on top of a surface, so it will have a normal force F normal, and then this force F which is applied at an angle 20 degrees, F applied. Together, you can draw it like this and get your full 4 marks, but I prefer guys for you to use the components of this applied force. Why? Because the force is applied at an angle and the object is not moving at that angle. The object is moving horizontal. So I would prefer you to draw a free body diagram that will have components. Yes, you'll still have normal force F normal, you'll still have E frictional force, you'll still have E weight. However, I'm going to break down this force which is applied at an angle into two forces. into its component. Firstly, there is a horizontal component. Ne? Why? Because the block is not moving at an angle, it's moving horizontally, and this force is pulling it towards the left. So the horizontal component should be at the left. Ne? For the horizontal component, you're going to call it to Fx, and that Fx will be equal to the magnitude of the force F multiplied by cos of 20 degrees. Are we together? And then obviously, if ever you have a horizontal component, you must have a vertical component as well. Are you together? Since the force is not pushed downwards at an angle, but it's being pulled at a slightly upwards angle, we must have a vertical component which is going up as well. Ne? The vertical component is Fy, and Fy is equal to the magnitude of F as well, multiplied by cosine of 20 degrees. Are you together? I prefer drawing my free body diagram like this. Not to say that this one will be wrong. I prefer to draw it like this. Why? Because whenever I'm doing calculations, I'm going to use the horizontal component or either the vertical component as well. Are you together? Okay. Now we must just show that the work done by kinetic friction on the block can be written like that. Okay. Work done by kinetic friction. The work done by a kinetic friction, Fk, should be equals to the force in question multiplied by the displacement covered in the direction of the force. Okay. For us to start, guys, we must first find the value of kinetic friction. Ne? How can you find the kinetic friction? Kinetic friction is equals to normal kinetic friction is equals to mu k multiplied by a normal force. Ne? What do you know about this thing? Is it moving at a constant speed or what? Okay, they never told us anything about constant speed. Okay, let's just find the frictional force first. Ne? We know that the coefficient is just 0.2. However, since we have a vertical component, a normal force is not equals to a gravitational force. Are we together? However, the upwards force, the sum of the two upwards forces will equal to a gravitational force. Are we together? Because the two forces are balanced. All the upwards forces should be equal to the downwards forces, which simply means that F net for the vertical component for the vertical forces is equals to 0. Are we together? Why? Because our block is not moving vertically. It simply means that the vertical forces are balanced. Are we together? So you can simply say that normal force plus the vertical component minus the gravitational force is equals to 0. I'm separating gravitational force because it is opposing the two upwards forces. So we can therefore conclude that in normal force here too is equals to a gravitational force minus the vertical component of the force F. Are you together? So now I do know the value of my normal the value of my normal force. Ne? I can just substitute it over here. It will be weight minus the vertical component. So that's still 0.2. Weight, for weight, I'll say 200 multiplied by 09.8 minus F sine of 20 degrees. Okay. 200 times 9.8, what do I get? 0.2 1960 minus sine of 20 degrees f. If I multiply everything inside the brackets by 0.2, I will have 392 minus 0.2 sine of 20 degrees multiplied by f in newtons. All of this gives us a frictional force. Please note that, guys, I haven't multiplied this as well, because I will get an irrational number, so I don't want to round off until I'm at the final answer. That's when I'm supposed to round off. So I'm going to take the frictional force as it is now. Okay. So frictional force, we know that it is equals to 392 minus 0.2 times sine of 20 degrees multiplied by f. The distance covered by the block must work done by frictional force. That's 3 meters. That's 3 meters. Cos of 180 degrees. Why 180 degrees? Because if you check, the direction of motion is going that way, and then frictional force is opposing the motion. The angle between the frictional force and the direction of motion is 180 degrees. So that's why I have 180 there. Work done by friction. This will still give me cos 180 multiplied by 3 will give me a negative 3, and I will still have my brackets. 392 minus 0.2 sine of 20 degrees cos f. Then now I can multiply by negative 3. Negative 3 times 392 will simply get negative 1176, and then negative 3 multiplied by negative 0.2 also multiplied by sine 20 degrees. This will give me 0.2052. It can be written as 0.205, and then we still have an f there. So all this is the magnitude of work done by friction. Are you together? Remember that work is an energy, and the SI units for energy, that's joules. So that's how, guys, we're supposed to show that a work energy, the work done by friction, can be written like that. Okay. Now we are supposed to calculate the magnitude of force F that has to be applied, so that the net work done by all the forces becomes 0. Okay, if work net is 0, guys, it simply means that F net is also 0. Simply means that there's no change in kinetic energy. Acceleration is 0 as well, and there's no change in velocity. Okay, for when F net is equal to 0, on the horizontal dimension, we only have two forces, the horizontal component and the frictional force. Are you together? We always take the direction of motion as positive. Are you together, guys? So that's why the horizontal component Fx will be positive plus a negative frictional force has to give us 0. So Fx minus frictional force is 0. Then Fx is equals to a frictional force. Are you together? But remember that I told you that The horizontal component is equals to F multiplied by cos of 20 degrees. Are you together? And then this is equals to frictional force. Frictional force, we got, what did we get? We got 392 minus 0.2 sine 20 degrees minus F. Not minus F, multiplied by F. Let me write the F in front. There's no difference in whether it's in front or at the end. We are trying to solve for F now, guys. So what we'll do is to take this term over here and take it to the other side. We'll have F cos of 20 degrees plus F multiplied by 0.2 sine of 20 degrees is equals to 392. Are you together? 392. We want to solve for F. Are you together, guys? We can take out a common factor. We'll be left with cos of 20 degrees plus 0.2 multiplied by the sine of 20 degrees is equal to 392. So therefore F is equal to 392 all over the cos of 20 degrees plus 0.2 sine of 20 degrees. 392 all over the cos of 20 degrees plus 0.2 times sine of 20 degrees. This will give us a magnitude of F as let me confirm that I didn't make a mistake. Okay, I didn't. 388.85 newtons. This should be the magnitude of force F, ne? 388. Let me write it neatly. Let me try, guys, to have a beautiful handwriting. Yeah, 388.85 newtons. So this should be the magnitude of force F for us to have an F net of 0, or for us to have the work net of 0 joules, right? But remember, if work net is equals to 0, F net is also equals to 0. And also kinetic energy is equals to 0. Change in kinetic energy rather is equals to 0. And acceleration is also 0. Why? Because the velocity is constant. Are we together? So that's how, guys, I was supposed to find force F. I hope the video helped you out, guys. Thank you for your time.